And my name is Elsa Jakira.
We are from section 803. So today we will discuss about question number 3. So the question asks us to find the time taken of the train to make a 9-kilometer trip in two situations. First, at which the train must stop 1.8 km apart with total of 6 stations, and for B, the station is 3 km apart with total of 4 stations. The train will accelerate 1.1 meter per second squared until 90 km per hour before it decelerate with negative 2 meter per second squared and stop at each station for 20 seconds. The concept that applied in this question is linear motion, and we are using the formula from kinematic equations. So here are the solutions.
For the question, the acceleration was given is 1.1 meter per second square, and for deceleration, it was given negative 2 meter per second square. The maximum speed of the train is 90 km per hour, so we have to change this 90 km per hour into SI unit of velocity, which is meter per second. So firstly, we have to find the time taken when the train is accelerate. So maximum speed is divided with acceleration of train. We can get the time taken when the train is accelerate, which is 22.73 seconds. So now we need to find delta x when the train is accelerate. So we can use this kinematic equation, which is v square equal to v naught square plus 2a delta x. And we can get the delta x when the train is accelerate, which is 284.09 meter. Now we have delta x when the train is accelerate and decelerate. So we need to find the constant delta x, which is when the train is constant. So 1800 is equal to delta x per station minus delta x accelerate and delta x decelerate, and we can get the constant delta x, which is 1359.66 meter. So this is the time taken when the train is constant. The question asks us to find the time taken to come across all 6 stations. So we use the time taken when the train is at acceleration, deceleration, and constant, and also the time taken when the train is stopped at 4 stations. So we multiply it with 4, and we can get 8.8 minutes. We multiply the time taken of train when it moves with 5 because due to 5 stations.
For question B, we are trying to find the time taken for acceleration by dividing the velocity with acceleration, and we got 22.73 seconds. And then for the delta x, we are using the kinematic equation v squared equal to v naught squared plus 2a delta x to find the delta x, which is 284.09 meter. For the deceleration state, we will also find the time taken for the train to decelerate, and then we will get 12.55 seconds. And then for the delta x, we are using the kinematic equation v squared equal to v naught squared plus 2a delta x, and we will get delta x as 156.25 meters. Now we have got the phase when it accelerates and when it decelerates. So now we are going to find the time taken and the delta x when the velocity is constant. Okay, now we find the delta x when it is constant is by subtracting the delta x for the whole station minus with the delta x when it accelerates and the delta x when it decelerates. So we will get 2559.66 meter. So to find the time taken when the velocity is constant, we need to take the delta x and divide it with the maximum speed, which is 25 meter per second, and then we'll get the time. Okay, so now back to the question, which asks us to find the total time taken from the first station until the fourth station. Okay, now we'll take the time taken for acceleration, time taken for deceleration, time taken when it is constant, and the time taken when it stops it at these two stations. The time taken at each station are the same, so we are multiplying all these times with 3 to symbolize all 3 stations. So that's all from us. Thank you.